Hello everyone. So today we are going to solve this LeetCode 295, which is find median from data stream. This is a hard problem, and this basically is something which uses heap effectively. So let's jump into the question first. So the median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value, and the median is the mean of the two middle values. Mean of the two middle values. Okay, this is interesting. For example, array 2, 3, 4, the median is 3. For example, array 2, 3, the median is 2 plus 3 divided by 2, which is 2.5. So for odd number of elements, the median is definitely the middle one. And for even number of elements, basically the median is the average of the middle two values. Okay, so implement the median finder class. Median finder initializes median finder objects. So you have to define some objects where the median finder will initialize those objects. Void add num end num, which takes num type parameter, adds integer num from the data stream to the data structure. So by dynamically we have to initialize some of our parameters, and we have to use this method and expect that it will be called, and we have to make use of this and add into the our data structure. And then double find median returns the median of all elements so far. So we need not to remove the elements. So far, all the elements that are being added into the add num method, being called into add number method, we have to just keep on returning the median based on the number of elements. So answers within 10 to the power minus 5 of the actual will be accepted. All right, so input is this median finder being initialized, add num, find median, then again add num, find median. So initialized 1 added, then again find, then 3, then this. So this is based on that output. So first median will be 1.5, second will be 2 of all three values. Okay, so this is an explanation, and all right, so let's jump into the solution. So basically this there are three methods which we have to complete, and the thing here is that we will see here the importance of heap data structure, and heap data structure so beautifully aligned that how the problem statement basically concludes the usage of those two heap data structure, which is minHeap and maxHeap, which classifies that if the median is the mean of the two middle values. So if we have lot of values, and median is the middle of two middle values. So if I use heap to get those two middle values out of the stream of data that are coming and being added in the add num method. So the two middle values will be calculated in somehow that I will use maxHeap and minHeap. So maxHeap will basically give me the minimum value among the, actually it gives the maximum value, but we will enter into the maxHeap all the minimum values from the data stream. Okay, and in the minHeap we will enter all the maximum values in the data stream. All right, so if we use maxHeap, we can in fact if we use maxHeap and add all the maximum values in the maxHeap, basically it will give me the last value. It won't give me the middle two values of the data stream. So eventually, let's jump into the solution. We will see later on how it goes. So we'll take two heaps being defined as priority queue data structure. Okay, priority queue, and here I will define it of integer minHeap, and then again priority queue defined as integer as maxHeap, and these two priority queue will be here in the slice as defined by the method median finder. And here I will say that minHeap will be by default is equal to new priority queue, and no need to pass comparator definition, and maxHeap will be new priority queue, and here we will pass it like the parameters as p comma q, where p comma q it will result into q minus p. All right, for maxHeap, otherwise else by default it's just p minus q being defined as the minHeap All right, so here we have the definitions being defined for find median finder, and next we will come to the addition. So this is a tricky part of this question. Why it is categorized, I think, as a hard problem lies in this add num method. So first we will use maxHeap to add the number, and the second step where we basically use the minHeap and add the maxHeap dot poll. So basically first we are putting into the maxHeap, okay, and then we are just taking out from the maxHeap and putting into the minHeap, because the maximum value from the maxHeaps are being taken away and put into the minHeap, so that we have all the maximum elements in minHeap, and among those maximum the smallest will be at the root node. So that will basically because we need to get the two elements to find the median. So now we got the three, which is the all the maximum elements and smallest element among those three, those inside the min heap, and we got 2, which is the upper bound from the max heap. So basically we will use these two values to calculate the median. So this is how the logic goes, why we are putting first into max heap and then taking the value and putting back into the min heap. All right, so uh, now the tricky part is that if while doing so we see that the max heap the size is smaller than the min heap dot size, because in this way we need to see that the max heap size should be bigger than the min heap size, because in that case we need not to calculate the median by division, it's just the middle part of the value as in the first example. So in that case we will basically do what is max heap dot add min heap dot poll. So the root node value of the min heap will be put into the max heap, okay, if the size is min heap is greater than the max heap. So in this way we will just keep on adding the values, and just we will come to the find median, where we will see that if in doing all these things, if max heap dot size is greater than min heap dot size, in that case return max heap dot peak. All right, and else if the size of max heap is not greater, it means we need to calculate the median. We need to return which will be max heap dot peak plus min heap dot peak, which are the root elements of this max heap and min heap, and basically from where did this y came up, and basically we need to divide these values by 2. We can have like division performed here, and we just need to return the median, and I think it should work. All right, okay, so this question was tricky in terms of manipulating with the max heap min heap. So the logic basically lies in these two statements, deriving from these two statements. For example, array 2 3 4, so we have these kind of values. So the max heap will contain 2 3 and the min heap will contain 4. So size is max heap is greater than the min heap, so we will just pick the element from the max heap, which will be 3, and this will get executed. Sorry, this part first. Considering the second example, the max heap and min heap size is equal, which is 2 and 3. The min heap contains 3, max heap contains 2. So in that case, basically, we need to just take out the value from max heap root and min heap root and do the addition, divide by 2 and return the median. So in this way it explains why the reason of this logic is being used. First putting in the max heap, so we usually get all the maximum value at the root node, and that maximum value has to be shifted into the min heap, because we need to get the middle two values, not the last, middle two values of the array, or the and the array is basically the streams of value data stream being added into this add num. So we want to get the middle two values. We want to get the middle two values, which will eventually be in terms of series of data. If we get this middle two values and we divide it, can get the median, else the max heap maximum value, which is in the root node, will be the median value in terms of odd number of data stream of values. So this was how this problem was being solved. This was a tricky problem in terms of thinking of how to pass the values from maxHeap to minHeap. Initially, I was also wondering about how the heap data structure would be used here, but finally here we go. This solution has been accepted. See you in the next problem.